Hi, so welcome to today's discussion. So today we'll be having discussions on post-hoc analysis, also known as multiple comparison. And you remember per the previous video that I did, which is one-way ANOVA, I indicated that when within the question, you realize it is in a directional fashion, that's one tilde, and you made a decision to reject HO, meaning that per the interpretation, you realize there's a significant difference between the groups. Then it means that you're supposed to do further analysis. Why? Because the F value that you got, which inform you that reject HO, will just tell you that, oh, there's a difference existing between the groups, but wouldn't be able to help you to find out where the difference in itself lies. So for instance, the question that we solved, we realized that we had three main groups. We have three main groups, and within the groups, we had group 1, group 2, and group 3. So what ANOVA will do is that ANOVA will compare group 1 and group 2, and again, we'll compare group 1 and group 3. Then we'll compare group 2 and group 3. So it means when the groups are 3, we are supposed to get 3 comparisons. So the F value will just tell you that, oh, there's a difference existing between these comparisons. But I wouldn't exactly tell you whether the difference exists between only the first comparison or all the 3 comparisons. So it means that since the F value that we've calculated wouldn't be able to help us know where the difference in itself lies, then it means you're supposed to do further analysis known as post-hoc analysis or multiple comparison. That will let us know that, oh, the difference we are talking about, it solely lies between group 1 and group 3, but the rest, they are not significant, or all the comparisons are significant. So that's what multiple comparison will do. And I'm repeating, for you to do multiple comparison, make sure that within the question, they stated the hypothesis in the question. That's the alternative hypothesis. You know you will get it in the question. Make sure that they indicated it in a directional form. And also, per your calculation, when you're doing the steps, the 6 steps, per your calculation, you were able to make a decision to reject HO. So when these 2 things are satisfied, you realize the H1 is directional and you rejected HO, telling you that there's a significant difference between the groups, then it means you have to move on and do multiple comparison. So you could see the previous question that we saw when it comes to ANOVA, that's nature of words on recall. You could see that per our final interpretation, we indicated that there is a significant difference. Why? Because we rejected HO. And when you check the question, they pose the hypothesis in a directional form because they indicated that one group would commit more errors than the other groups, which is a typical directional hypothesis. Hence, we are supposed to do further analysis, that's post-hoc analysis. So you can see, this is the question that we saw when it comes to the ANOVA that we did. And the latter part, what I've italicized, that was the question or the alternative hypothesis we found in the question. And when we read, you can see that they indicated that participants in the taboo words only will commit more errors than the other two conditions or two groups. So when you deduce this hypothesis, what it implies is that they compared taboo words only with neutral words only. And you are saying that when you compare taboo words only with neutral words only, taboo words only would commit more errors than neutral words only. And then again, when you compare taboo words only with participants in both nature of words, that's neutral and taboo words, those in taboo words only will commit more errors than participants in both neutral and taboo words. So these are the key indicators they spell out when it comes to their hypothesis. These are the key things they indicated, that definitely taboo words only will commit more errors than neutral words only. Then again, taboo words only will commit more errors than those in both conditions. Okay. So it means you are supposed to solve using something known as least significant difference. And why did we use least significant difference? Before we talk about we delve more into least significant difference. One thing about post-hoc analysis is that we compare the means of the groups, the mean values of the groups. We compare them and find out. So the mean values will let us know whether there's a significant difference or not. That's one key thing you should know. And in conducting post-hoc analysis, we have different types. So I have indicated some of the types, and that's what I just highlighted. We have Tukey test, protected t-test, LSD, then Duncan's multiple range test, then Bonferroni test. All these are multiple comparison tests that we do. But our focus when it comes to this discussion will be on two of them. That's LSD and protected t-test. So when do we use LSD? We use LSD when you realize that the sample size for the groups that you are comparing, they are all the same. So you can see per the question that we saw when it comes to ANOVA, the sample size for the three groups, they were 7 each, 7 each, because we have 7 participants each. So it means they have equal sample size. And since they have equal sample size, then it means the best post-hoc analysis to do is LSD. That's least significant difference. And how do we solve LSD? To solve for LSD, we use this formula. And per the formula, we have something known as MSW. The MSW is the same as the mean square for between. So it means per your calculation for ANOVA, you had a value for mean square for within. And that's the value that you will use when solving for the LSD. So when you check the previous video that I did, when we solved for the MSW, we had the value to be 1.777778. So that's the value that we'll be using. Then within the formula 2 for LSD, we have small n. This small n definitely represents the sample size. And you could see that the sample size for the groups, all the three groups, they were 7 each. So it means our sample size should be 7. Then you can see that within the formula, we have T in there. So you ask yourself, what is T? What T value are we solving? It means that with the LSD, we are supposed to solve T critical. That will be our T. So like when we're doing all the T tests, remember we're solving for T critical. And you know, to solve for T critical, you need 3 key things. You need a level of significance, the degree of freedom, and whether the hypothesis is directional or non-directional. And when you check the ANOVA question that we saw, they didn't provide any level of significance in the question. So we assume that the level of significance is 0.05. Also, even though within the question, they indicated the H1 in a directional fashion. You remember I said, even though they've indicated it in a directional fashion, always put your hypothesis in a non-directional fashion. So it means we are assuming that our hypothesis is in a non-directional form. So it means it is non-directional. Then the next thing for us to do is to find the degree of freedom. And you know, when it comes to ANOVA, our degree of freedom is always the degree of freedom. We calculate two things: degree of freedom for between and degree of freedom for within. Our emphasis when calculating for LSD, our emphasis should be on degree of freedom for within. And you know the formula for degree of freedom for within, that's N minus K. And you know what big N represents? It represents the total number of participants in all the groups. So we have 7 participants each. So it means it will be 7 plus 7 plus 7, which will be 21. And you know what K represents? It represents the total number of groups. And the groups were how many? 3, meaning our degree of freedom for within will be 18. So it means we've been able to deduce these 3 key things. Our level of significance is 0.05. Our hypothesis is non-directional. And our degree of freedom is 18. So definitely we can find the T critical that we want. And to solve for any critical value, you know how to do it. You are supposed to use the critical value table. Although we solve for ANOVA, our emphasis is on ANOVA, go through the formula table and use the critical values of T table, because we are solving for LSD and we want the T critical. Our focus should be on the critical values of T, not F. So under critical values of T, we were able to deduce that our level of significance is 0.05 and the hypothesis was non-directional. So since it is non-directional, it means that our hypothesis is two-tailed. So it means you're supposed to select one of these level of significance. And we're able to deduce that it is 0.05. And when you convert 0.05 into percentage, it will be 5%, meaning that you're supposed to read our information here. You're supposed to select one of these values. Then you ask yourself, which of the values should I select? We're able to deduce that our degree of freedom, since we use degree of freedom for within, we calculated and had a degree of freedom for within to be 18. So it means our degree of freedom we'll be using is 18. Hence, we are supposed to select this value as our T critical. And that's the T critical value we'll be using to solve the LSD. So it means our T critical is 2.101. 2.101. So per what we have here, we're able to deduce that the T critical is 2.101. And that's the T value that we want for the LSD. So it means we know the T value to be 2.101, and we know our mean square value. We know the small n. Hence, we can easily substitute the values into the LSD formula. So it means when you substitute, this is how it should be. 2.101, which is the T, times square root of 2 times mean square for within, which is 1.7777 and so on, over n, which is 7. And when you calculate, you are supposed to get an LSD value of 1.497. 1.497. This 1.497 tells us that for us to say that there is a significant difference existing between two groups that we'll be comparing, for us to say that there's a significant difference between two groups, then it means that the least difference or the least mean difference we should find between the two groups should be 1.497, meaning that when we find mean difference between the two groups, we should have a value that is 1.497 or greater than 1.497 for us to conclude that there is a significant difference between the two groups. So remember I said with multiple comparison, our focus is finding the mean difference between the groups. So it means that after we've generated the LSD, we need to find the mean difference existing between the groups that we want. And per the question, we're able to deduce that we are supposed to find mean difference between these conditions or these comparisons. Let me copy them here. It means you're supposed to find the mean difference between taboo words and neutral words. Then we find the difference between them. And how would we find the mean difference? For us to find any difference, it means you're supposed to find the mean of taboo words, the mean value for taboo words only, then the mean value for neutral words only. And you know how to solve means. So per the previous calculations that we did with 1 way and over, when you check this table, you can see that with neutral words, we had sigma x to be 24, taboo words to be 47, then both words to be 29. So it means for us to find the mean for neutral words, it will be sigma x over n. And currently we know sigma x to be 24 over 7. So it means the neutral words, its mean value is 3.429. Then taboo words, its mean value is this. Then with taboo words of both words, its mean value is what? 4.143. So these are the key things we need to do our comparison. So right now we know the means of the various groups. And we are supposed to find out whether taboo words only committed more errors than neutral words. When you check the means for taboo words, it's 6.714. Then neutral words is what? 3.429. It means that we need to find the difference between the two groups because our emphasis is on comparing taboo words and neutral words only. And for us to compare, we use the means. So that's what I've done here. When you check group one implies that we have neutral words. So it means you are comparing. It means you are comparing neutral words only and taboo words only. And what did we get for neutral words? Its mean. We had its mean to be 3.429, and that's what is here. Then with taboo words, we had its mean to be 6.714. And we want the difference. So it means you're supposed to subtract the means of the two. And when you subtract, you will get 3.285. This difference that we found, we will then compare it, we will compare this difference with the LSD. So for us to say that, oh, this mean difference, which is 3.285, for us to say that it is significant, as I indicated, it should be equal to or greater than the LSD value. So the moment it is this mean difference is equal to or greater than the LSD value, then we can say for sure that, oh, there's a significant difference between the two groups. That's taboo words only and neutral words only. So when you check, you could see that 3.285 is greater than the LSD value. And that should inform you that there is a significant difference between neutral words only and taboo words only. But you ask yourself, which of the groups committed more errors? Although we are saying there's a difference, which of the groups committed more errors than the other? And the group that committed more errors will be the one that had a large mean. And you can see that taboo words only, they had a mean value of 6.714. Then neutral had 3.429. And that should tell you that taboo words only, or participants in taboo words only, committed more errors than those in neutral words only. So that means it satisfies the first hypothesis formulated by the researchers. You know, the researchers, they indicated that participants in taboo words only will commit more errors than neutral words only, and also commit more errors than those in both neutral and taboo. So right now we know that participants in taboo words only committed more errors than neutral words only. Let's find out what of taboo words only and those in both nature of words. And for us to do that, it means that will be the group 2 and group 3, because group 2 is for taboo words. So it means taboo words, you are supposed to find out the comparison between taboo words only and those in combination of taboo and neutral words. Okay, so when you check, you will see that taboo words only, we had the mean to be 6.714, and that's what is here. And those in combination of taboo and neutral, we had the mean value to be 4.143. And when you subtract, you're supposed to get a value of 2.571. So after you've found the mean difference between the two groups, you're supposed to compare this mean value or this mean difference with the LSD. And like what we did for the previous comparison, if this mean difference is greater than or equal to the LSD value, then it implies that we need to indicate that there is a significant difference between the two groups that we were comparing. And when you check, 2.571 is greater than 1.497, meaning that there is a significant difference between taboo words only and combination of taboo words and neutral words. So it means there's a significant difference between the two main groups here, taboo words only and participants in both taboo and neutral words. Then again, you ask yourself, which of the group committed more errors? Because the number of errors, that's our dependent variable. So we want to find out which of the groups committed more errors than the other. And like what we did for the previous one, we use the means. When you realize that the mean is greater than the other, then that should tell you that the one with a larger mean committed more errors. So you could see taboo words only, that's their mean, 6.714, is larger than 4.143. And we were able to deduce that there's a significant difference. So that should tell you that taboo words only significantly committed more errors than neutral words only. So it means that the researchers, their hypothesis has been satisfied because they hypothesized that participants in taboo words only will will commit more errors than participants in group group one, which is neutral words only, and group three, which is participants in combination of neutral words and taboo words. And we're able to deduce that taboo words, definitely, they committed more errors than the other two groups. Hence, the researchers' hypothesis that more errors will be made under taboo words only than the two other conditions, that's neutral words only and neutral and taboo words condition, were true. So that's how you do the multiple comparison for LSD. Okay. Then the next one is protected t-test. Protected t-test. We normally use protected t-test when this time around the sample size, when the sample size, they are different. So you could see that per the one that we did, the question that we saw, the sample size, they were the same. So that's why we selected LSD as the multiple comparison or as our post-hoc analysis. But in an instance whereby within the question, H1 is directional and we made a decision to reject HO, but our sample size for the groups are different, then it means you can't use you can't use LSD or least significant difference. Hence, you are supposed to use protected t-test to do the comparisons, to find out which of the comparisons are significant and all that. So we are using the same question for the ANOVA, one-way ANOVA. But this time around, we are assuming that the sample size for neutral words is 7, then for taboo words only is 8, and participants in both nature of words are 9. So we are assuming that this is our sample size for the three groups, 7, 8, 9. And we also are assuming that after calculations, we had a mean value of 3.43, 6.71, and 4.14 for participants in neutral words only, taboo words only, and those in both conditions respectively. So these are the assumptions we are making. So how do we solve? Using protected t-test. This time around, we are using protected t because of the fact that our sample size, they are not the same because we have 7, 8, 9. So for us to solve, it means we need to use this formula, and this formula is normally provided, the protected t-test formula. And when you check the formula, the numerator that you have there is the sample size for the two groups that you're comparing. It's for the sample size. So let's assume that then again, they made a hypothesis. They hypothesized that, the researchers hypothesized that again, participants in taboo words only will commit more errors than those in neutral words only and both conditions. Like what we did for the previous one, the same hypothesis. What we did for LSD. Then it implies that you're supposed to compare Again, taboo words only and neutral words only, and also taboo words only and those in both conditions. For us to solve that, it means we are supposed to find the mean value for taboo words only and neutral words only. We need to find the mean value. And let's assume that we've already calculated the mean values. And we had the mean value for taboo words only to be 6.71. And the mean value for neutral words to be 3.43. And also, let's assume per the calculations that we did, because per the ANOVA calculations that we did, we had a mean square value of 1.7778. So we are using the same mean square value because within the protected t-test, we have a mean square there. It means you are supposed to calculate that mean square value. So let's say per our calculations, we had a mean square value to be 1.77778. Then it means for us to calculate anything, we need to use this. So first, we are comparing taboo words only and neutral words only. And as I indicated, we are assuming that our mean value was 6.71. We've already calculated it. And our neutral words only, its mean value was 3.43. Okay. So per the formula here, let me copy and paste it here. Per the formula here, it means that I couldn't get, as I said, I couldn't get the symbol for the sample mean, which is something like this. So let's assume that this is the sample mean for taboo words, and this is the sample mean for neutral words. So it means per the protected T formula, we are supposed to find the difference between the mean difference between taboo words only and neutral words only. And that will be 6.71 minus 3.43 over square root of, we know mean square for within, we know mean square for within to be 1.7778, and that's what is here, into bracket 1 over n1. The ni that you see there is for the sample size for the first value there, which is taboo words. So the sample size, we indicated that the sample size for taboo words only is supposed to be, when you check, we assume that the sample size for taboo words only is supposed to be 8. Then the sample size for neutral is supposed to be 7. So it means that in here, it will be 1 over 8 plus 1 over 7. So when you calculate this, you're supposed to get a T critical value of 4.753. Sorry, so this is the T observed value that we want. So after you've gotten this value, you're supposed to compare this T observed value with your T critical. You're supposed to compare this T observed value, the protected T test value that you have. We are assuming that it is the T observed value. And you're supposed to compare this T observed value with a T critical. So it means with the protected T, like what we did for LSD, we need to get a critical value in there. And we use the same thing. The same assumptions. You need to find out the degree of freedom, the level of significance, and whether your hypothesis is directional or non-directional. And when you check within the question that we saw, you could see that they didn't provide a level of significance. So we are assuming that our level of significance is 0.05. And although they stated the hypothesis in a directional fashion, we are assuming that it is non-directional, and our degree of freedom, we normally use the degree of freedom for within, which will be n minus k. This time around, you could see that our sample size, they were different. We had 7, 8, 9. Group 1, their sample size was 7, group 2, 8, group 3, 9. So when you combine or when you sum 7, 8, 9, you have 24, which will be 24 minus the total number of groups, which is 3. So it means our degree of freedom here will be 21. We'll use these 3 indicators to generate the critical value table that we want, the critical value that we want for T. So like LSD, we'll use the critical values of T to get our critical value for our protected T. And we were able to deduce that the hypothesis is two-tailed. So it means you are supposed to indicate or read our information here. And the level of significance was 5%. Was 5%. Okay. So you are supposed to read our information here. And our level of significance is 5%, meaning that we are supposed to read our information from this side. Then you ask yourself, which of the values should I select? Since we had degree of freedom for within to be 21, it means we are supposed to use this value, which is 2.081. So it means the critical value that we want is 2.080, and that will be the critical value that we'll be using. Okay. So after you've generated your critical value, you then set your decision rule. Because for us to first solve the protected t-test, you know the protected t-test, I said, assume that it's more or less like we are trying to solve t observed. So we are setting a rule that if our t observed is greater than 2.080, which is the critical value, we are supposed to if it is less than 2.080, we are supposed to retain HO. And if the t observed is greater than or less than 2.080, we are supposed to reject HO. And per our calculation for the protected t-test, we had it to be 4.753. It means this is the t observed value that we are looking out for. And per this, when you compare this with the decision rule we've stated here, you could see that 4.753 is greater than 2.080, meaning that we are supposed to reject HO. And when you are rejecting HO, it implies that you are telling your reader that there is a significant difference between the groups that you were comparing. And per the protected t-test, which of the two groups were we comparing? We're comparing taboo words only and neutral words only. And we've made a decision to reject HO, meaning there is a significant difference between taboo words only and neutral words only. Then you ask yourself, which of the two groups committed more errors than the other? Like what we did for LSD, we used the means. And you could see that the mean value for taboo words is greater than neutral words, meaning that participants in taboo words only committed more errors than those in the neutral words only, which is significant. Okay. Then the next comparison, right now we've done the first comparison. The next comparison that we have to do is to find out whether there's a difference between taboo words only and participants in both nature of words. It means you're supposed to do another calculation for protected t-test. This time around, the main difference here will be for taboo words only, which is 6.71. Then those in both conditions, which is 4.14. So it will be 7.71 minus 4.14 over square root of the mean square for between times 1/8, because the sample size for taboo words only was 8, plus 1/9 because the sample size for participants in both conditions were 9. And when you calculate, you're supposed to get a t observed value of 3.967. Then afterwards, again, you're supposed to compare this t observed with our decision rule, which is this one. So let me paste it here. You're supposed to compare the protected t observed value here with our decision rule. And you could see that 3.967 is greater than 2.080, meaning that what are we supposed to do? We have to reject HO. So since we are rejecting HO, it means that we are telling our reader that there is a significant difference between the two groups that we're comparing. And which of the two groups were we comparing? That's taboo words only and participants in both nature of words. So we are saying that there's a difference between the two groups. Then again, you ask yourself, which of the two groups committed more errors than the other? Definitely, since there's a significant difference, it means you're supposed to use the means for the two groups. And when you check, the mean value for taboo words only is greater than participants in both conditions. So hence, or that should tell you that participants in taboo words only committed more errors than participants who happen to be in neutral words and taboo words. So it implies that group 2 committed more errors than group 3. And since these are the two main comparisons that the researcher the researcher hypothesized, and all of them were significant, then that should tell you that indeed more errors were made under taboo words only than participants in neutral words only and those in both conditions. So that's how you calculate protected t-test and LSD. So that will be the end of today's discussion. Thank you.